Something extraordinary had just entered our solar system. Not a comet, not an asteroid. Something entirely different. On the night of July 1st, 2025, astronomer Edward sat alone in the quiet, cold dome of the Atlas telescope in Rio Gerardo, Chile. A cup of coffee steamed beside him as his eyes scanned the familiar streams of moving dots on his computer screen. Every night, Edward tracked these dots. Tiny, distant rocks already catalogued, already mapped. A routine. Predictable. Safe. Until that night when one dot refused to behave. It didn't match any known asteroid. Its motion was erratic. Its velocity impossible. And then Edward realized the numbers. They didn't just break the rules of our solar system. They shattered them. This object was moving way too fast. Faster than anything astronomers had ever recorded. Faster than any comet, any asteroid, anything we had ever catalogued. And in that instant, Edward understood. This visitor had not come from our sun. It had come from another star system entirely. He leaned back in his chair, staring at the screen as the cold Chilean wind whispered outside the dome. For a moment, time itself seemed to pause. Edward began to run the orbit backwards, tracing its path through the solar system, past Neptune, past the Kuiper belt, and into interstellar space. Millions of years of travel, perhaps even billions. At 58 kilometers per second, 130,000 miles per hour, this object had circled Earth in 11 minutes and could travel from here to the moon in under 2 hours. The universe had just delivered something ancient, something extraordinary, and humanity had no idea it was coming. The object was initially a string of random letters and numbers assigned by the Atlas system. But the velocity numbers didn't make sense. Edward recalculated, triple-checked, even verified against multiple databases. The results were identical. Eccentricity over 6. Anything orbiting our sun must have an eccentricity less than 1. This object? 6? Impossible. Professor David Jewett, co-discoverer of the Kuiper belt, later explained that the sheer speed alone meant this object had been traveling for eons. It wasn't just old. It was a time capsule from the galaxy's distant past. 10 days later, at the UK National Astronomy meeting, young astronomer Matthew Hopkins stepped to the podium. The room was packed with colleagues, all eager to hear what this bizarre interstellar visitor had in store. By now, it had a name. 3I/ATLAS, the third confirmed interstellar object. Hopkins revealed the trajectory. At first glance, it appeared normal, a cometary arc swinging near the sun and back into space. But then came the analysis that left everyone stunned. When tracing the path back, accounting for stellar gravitation and galactic rotation, the object did not follow the plane of the Milky Way's thin disk. It originated in the thick disk, a region of ancient stars far older than our sun. Hopkins revealed the number that silenced the room. 10 billion years old, perhaps even older. If that estimate held, this could be the oldest comet ever observed in human history. It wasn't just its age that intrigued scientists. The composition, the behavior, the trajectory, everything defied conventional expectations. By July 21st, the Hubble Space Telescope targeted 3I/ATLAS. At 277 million miles away, it raced across the sky so quickly that Hubble tracked it like one would a fleeting bird, collecting photons pixel by pixel. The images revealed a teardrop-shaped dust cloud surrounding the nucleus, ancient particles trapped in ice, sublimating directly into gas. The nucleus measured roughly 5 kilometers across, small enough to be unassuming, yet enormous in significance, containing material older than any planet in our solar system. By August 6th, the James Webb Space Telescope examined it in infrared. The findings were extraordinary. Instead of water vapor typical of comets in our solar system, carbon dioxide dominated the outgassing. This comet had never been near a star before. Its materials were pristine, untouched by solar radiation, frozen since the dawn of the galaxy. But the surprises didn't stop there. In early September, astronomers noticed something disturbing. 3I/ATLAS was releasing massive amounts of CO2, but its trajectory remained perfectly unchanged. Comets normally accelerate in reaction to gas outgassing, like a tiny rocket engine. Not this one. Either it was unbelievably dense, or some unseen force was maintaining its course. Avi Loeb, Israeli-American physicist and former chair of Harvard's astronomy department, examined its origin. His calculations pointed to Sagittarius, aligning intriguingly with the infamous 1977 WOW signal, a 72-second burst of radio energy 30 times stronger than the cosmic background, recorded by Jerry Amon at the Big Ear Radio Telescope. The probability of alignment? 0.6%. Even more intriguing, amateur radio astronomers reported brief signals near 3I/ATLAS in early August. 11-second bursts repeating prime numbers 2, 3, 5, 7, 11, 13, 17. Prime numbers, universal and intentional, are considered the simplest method of intelligent communication. If verified, this would hint at something artificial. Meanwhile, Christina Gomez and other space anomaly reporters documented structured sounds emanating from the object every 22 minutes. Loeb's Galileo project began continuous observation, not merely to track, but to monitor for unusual activity, potentially mini-probes released from the object. Harvard's top scientists were now openly entertaining what once was science fiction, that 3I/ATLAS could be an extraterrestrial probe. On October 3rd, history was set. For the first time, humanity could observe an interstellar object passing near another planet, Mars. NASA's fleet of orbiters, including the Mars Reconnaissance Orbiter, Mars Express, and ExoMars Trace Gas Orbiter, was poised for detailed observation during its 29 million kilometer closest approach. Yet NASA released only one low-resolution image, showing an elongated streak, 4 pixels long. Social media erupted. Tic-tac, alien cylinder? But Avi Loeb clarified, the spatial resolution was 12,500 kilometers per pixel. The streak wasn't a craft, it was a time-lapse artifact, a trick of distance and stacking exposures. High-resolution instruments, including HiRISE, had captured precise data, but NASA hadn't released it yet, citing processing delays. European Space Agency telescopes captured 5-second exposures showing something stranger. The comet's tail, previously visible, had disappeared. Some speculated it was hit by a coronal mass ejection. Yet, the tail's disappearance and delayed reformation contradicted solar physics. Amateur astronomer Michael Jorga in Namibia photographed a vivid green glow around 3/ATLAS. The same week, multiple amateur astronomers confirmed the anomaly. If 3I/ATLAS was artificial, this perihelion could be precisely when it activates. The notion sent shivers through some scientists. A perfectly timed, hidden transformation, invisible from Earth. Conspiracy theories circulated online. Some invoked Project Bluebeam, speculating about staged revelations or alien interventions. While most scientists dismissed this, the timing, massive public interest, anomalous signals, and perihelion invisibility created unease in both media and academia. December 2025 approaches, and humanity braces for the unknown. Observations from the European Space Agency's JUICE spacecraft are scheduled post-perihelion, but the data won't be available until February 2026. For weeks, 3I/ATLAS will remain unseen, and the question isn't if it will emerge, it's what it will reveal. Is it merely a comet from another star? Or is it something far more extraordinary, possibly artificial, possibly intentional? Scientists, amateurs, and space enthusiasts alike are poised for the event that may rewrite our understanding of the universe. This is more than a celestial object. It is a time capsule, a potential messenger, a mystery older than Earth itself. The universe has delivered 3I/ATLAS, and for the first time in history, we have the chance to witness something truly beyond comprehension. Whatever happens in December, the implications are staggering. And as the telescopes remain blind, one thing is certain. The story of 3I/ATLAS is only beginning.